Assalamualaikum and hi. Before we start the discussion, let's introduce ourselves first. My name is Iman Zakia binti Muhammad Azam and my matrix number is 212856. Next person, please.
Hi, my name is Muhammad Islam bin Azmi, matric number 212655. And next person.
Hello, my name is Farah Alisa binti Faizan. My matrix number is 212588.
Hi, my name is Sishulit with matrix number 212-869.
So in this video, we are going to check our progress. So as we have discussed before, we are contemplating on choosing engineering problem, which is from the electrical engineering and industrial engineering. But after we did some calculation on both problem, I think we decided to choose industrial engineering as our main problem, right?
Yes, I think industrial engineering are easier in terms of the calculation.
I also found the calculation of the industry engineering problem is better than the electrical engineering problems.
Yes, same with me, because in electrical engineering problem, there are some terms that we didn't learn yet. So I think industrial is better.
So thank you for your opinions. So I will explain about my part. My part is introduction and engineering problem. So in introduction, I did some explanation about the basic term of exact differential equation, which is this one. And then I also explained about the Euler method and I state the terms of it, which is this one. So after that, I did state that in Euler method, we can approximate the curve of solution by tangent each interval steps of h, where in general, if we use small step sizes of h, the accuracy of approximation will increase. As we've been told in the instruction, we need to justify why we choose the engineering problem, which is ours is about the open loop system industrial engineering. I did explain a little bit about the open loop system and an example of it. I also state the reason why we choose the problem, which is open loop system has been used in many machines in every engineering industry. Our casework can be used for other people as one of their resources on solving their differential equation to get the accurate output value for their problems. And for the reason on why we choose it, I didn't finalize it yet, but I think it will be probably there will be some changes to it. For engineering problem, wait, I just relate the introduction with it, and I just state the equation of our engineering problem, and I think that's all for my part. Next person, thank you.
Okay, to begin with, I use Glenn James textbook, Modern Engineering Mathematics, page 828 to solve the questions. So it takes me some time to figure out how it's working, and even with the book's assistance, I was unable to solve the difficult problem. And finally, after analyzing the textbook example, I was capable of tabulating the data for Euler's approach. So this is the numerical method. And to begin calculating, I utilize the formula that is currently displayed on the screen. Okay. Because the question stated that the initial speed is 0 at 0 seconds and the motor speed is 0 radian per second, I simply plug or substitute the number into the given formula to obtain the W subscript 1. Okay, so after getting the W subscript 1, I tabulate the data. So here is how the data table appears. Iman, can you show the data? Okay, as you can see, this is only a raw data computation, but this data will be tabulated into Excel later to generate the graph. Can you show the graph? Okay, so this is the graph, how it looks like after it has been keyed in the Excel. So that's all from me.
So you sure you can explain about your part?
For me, uh, like show at the screen. Let me explain some explanation about the method that we use, which is the integrating factor method. And in the mathematically, the integrating factor is a function that is chosen to facilitate the solving of given equation involving the differential. And it is commonly used to solve the ordinary differential equation, but it also used within the multivariable calculation when multiplying through by an integrating for allow an inexact differential to be made into an exact differential. And to solve this problem, I just give the general idea. First of all, we must make sure the equation is in the normal form, which is the dw over dt times p of t times w equals to q of t. And after that, we need to find the integrating factor using the if is equal to exponent of integration t with respect to t. And in the third step, we need to multiply the entire equation by the integrating factor. And next, we just integrate both sides. And finally, the left side will become the integrating factor of y. So by using an integrating factor, we able to get an exact solution which able to show a perfect stretcher string curve. So that's all for my part.
So Islan, you can continue your part.
Yeah, can you show the graph for the comparison? Yes. The top one. So scroll to the top. Okay. Okay. Okay, with the table. Okay, with the okay. So from the data that have been obtained in the table, we can plot the graph times, again, motor speed. So here I'm using an application, Microsoft Excel, to generate the graph. For the step size h equal to 0.4, we use a blue table and blue line, while h equal to 0.2, we use a yellow table and yellow line. And for the integrated factor or the exact differential equation, we using green table and green line. So here our graph outcomes. Then so after that, we can calculate the percentage error using the formula experimental value. Here is the formula for percentage error. So experimental value minus theoretical value divided by theoretical value times 100. So show me the graph. So in this case, the experimental value is the numerical method, and the theoretical value is integrated factor method. So and use the data to plot the graph where the blue line represents step size h equal to 0.4 and orange is represent h equal to 0.2. So then finally for the conclusion, we're going to make a conclusion on this assignment that there are many ways to solve ordinary differential equation. For example, Euler's method. So Euler's method is the simplest numerical method and most intuitive approach to numerical solving a differentiation equation compared to Roche-Kutta method, which is more complicated. So anyone want to add up?
I
This
think by
is
using the exact method, it is like more near to the exact value rather than we use the Euler method, right?
yeah.
Yes.
So if we use the exact method, it will come, the data will come more accurate. Like that.
I think that's all from us, but is there anyone to add something? No?
May I add something?
Sure.
I just want to say about the advantages and the disadvantages for the Euler method. The advantages for the Euler method is it is simple and direct, and it can be used for a nonlinear equation. However, the disadvantage of this method is it is less accurate and numerical unstable because this method is only the first order conversion. And for this method, the approximation error is proportional to the step size h. So a good approximation is obtained with a very small h. It means that the more smaller the h, the more accurate the data shown. Therefore, in this situation, it required a too small step to achieve some serious accuracy. For example, if we need 100 times more accuracy, we will have to take 100 times as many steps to achieve it. That's all for me.
So I think in conclusion, Islan can use some of the issue points and you can add it into your conclusion later. Is it okay?
Yes.
Okay. I think that's all. Is there anyone want to add something? No?
No, I'm fine.
I think that's all from us and thank you.
Thank you.
Thank
Thank
you.
you.